You can hear me, no? Okay. So can you see my screen?
Yes.
Sorry. Thank you. Okay. Okay, we will start our session. So still we are in counters part, no? Still we are in this part. Okay. Counters. Okay. And we already discussed that those are MSI sequential logic circuit. Okay. MSI means medium scale integration, integrated circuit. Medium scale IC. Okay. So these counters are coming as integrated circuits, normally in, commercially available as IC. Okay. So I think we have done the basic operation. No? We have done the basic operation. Okay. So last week we have seen. Okay. In last week we have seen. Actually, we get only a part of this circuit. Okay. We get only two flip-flops. I think you can remember, no? We got only two flip-flops. Okay. And if we send a clock pulse here like this, okay, I ask you to find the waveform at this Q0 and this Q1. Okay. So can you do that one? Now, is it okay for you? It is very simple, no? It is not much difficult. Okay. So you know that this is a negative edge triggered flip-flops. Okay. So you have the what is called the function table of the flip-flops. Okay. And you can see the bits, how the bits are changing here at Q0 according to this clock input. Okay. So it will look like this. I think you can remember that one. No? We have found this one. Okay. So I think now you can draw the signal at this Q0, no issue. Okay. So you have to see only the changes. Okay. And I already told you that if the frequency of this signal is F, okay, then the frequency of this signal, that means at the Q0, okay. So this is the clock signal. If the clock signal frequency is F, okay, the frequency at this first flip-flops, the frequency of the waveform at this first flip-flops will be F by 2. Okay. And the second, I asked you to find, the waveform at Q1. Okay. And also I asked you to find the frequency. What is the frequency value? If the clock pulse is in frequency F, what is the frequency here? Have you found that? What is the frequency here?
0.25F.
Sorry?
0.25F.
Yeah, 0.25F. So that is F by 4. No? Okay. So the waveform will look like this. Okay. So you can see that this is the one clock cycle. This is a one clock cycle. And this is another clock cycle. Okay. So up to from here to here, there are two clock cycles. Okay. But if you see in Q0, from here to here, there is one cycle. No? Okay. There is one cycle. So in the same time, you have two cycle at the clock input, but one cycle at the output waveform. So if the frequency f is here, the frequency of this waveform should be f by 2. Okay. And if you consider this signal, okay, if you consider this signal, that means the waveform at the Q1, okay, waveform at the Q1, okay. So you can see that here you have 1, 2, 3, 4 cycle. Here you have up to from here to here, you have 4 cycle, okay. You have 4 cycle from here to here, 1, 2, 3, 4, 4 cycle. But you can see that from here to here, you have only 1 cycle. Okay, here you have four cycle. In the clock input, you have 4 cycle. At the same time, here you have 1 cycle. So this frequency should be f by 4. Okay, in the same manner, I hope you can find the waveform at Q2 and waveform at Q3. Okay, so any of you want any help to find the waveform here? Please feedback. If you already know how to find the waveform at Q2 and Q3, it is okay. It is same as we find the waveform at Q0 and Q1. Okay, no any difference. In the same manner, you can find the waveform at Q2 and Q3. Only difference is for these flip-flops. Okay, for first flip-flops, the input clock is the real clock pulse. Okay, but for the second one, the input clock signal will be the Q0 output. Okay, so this output will be the clock signal here. Okay, so only difference is the frequency is changed. Okay, and the clock signal input clock signal to this flip flops will be output of this one, Q1 waveform. Okay, so that is the only difference. Okay. So I hope you should be able to find the waveform at these flip-flops. Okay. So what about? So can you do that by yourself, or you need any help from me? Can you feedback? Should I find the waveform at Q2 or Q3? මම මේ වගේ waveform හොයන්න ඕනද නැත්නම් ඔය කට්ටියට තනියම හොයාගන්න පුළුවන්? මොකක් හරි help එකක් ඕනද? Do you need any help from me, or you can do it by yourself? I hope no any feedback. Okay, so I hope you can find the waveform at Q2 and Q3. Okay. Okay, so I think you can do it. Okay, no issue. Okay. Okay, so we will move further then. Okay, so okay, anyway, I will find the Q2 output also. Output here. This output, okay, Q2, that means flip-flop 2, okay, FF2 output, okay. So we need the function table of JK flip-flops. Can anyone tell me? Please tell me, someone, how the function table look like for JK flip-flops. So this will be Qn plus 1, okay. you have J, here you have K, here you have Qn plus 1. Okay, and J can be 0, 1, 1, 0, 1, 0, 0, 0, 1, 1. Okay, so can you tell me the value at Qn plus 1, please? And from,
0.
this is 0, no?
Yes.
Set, no, reset. So this is 1.
1.
Yeah, that means set. Okay. So what is this? Qn or Qn bar?
Qn.
Okay. Qn, and this is toggle, no? Qn bar. Okay. So this is the function table for JK flip-flops. Okay. So we need to use this table. Okay. We need to use this table, and I'm going to find the waveformat Q2. Okay. I'm going to find the waveformat Q2 here. Okay. So you can see that the clock input. So this is a negative edge triggered flip-flops. Okay. So the flip-flops shift to active mode at the negative edge of the clock cycle, negative of edge of the clock signal. No, the flip-flops turn to active mode when the negative edge happen. Falling edge is there at the clock signal. Okay, so you can see that if you consider FF2, okay, if you consider FF2, the input signal will be, the input clock will be QN1 signal, no? QN1 waveform. So for FF2, the clock signal is the output of Q1. Okay, output of the Q1. Okay, so what is the Q1 waveform? So this is the Q1 waveform. Okay, so this is the Q1 waveform. So this will be the clock signal for FF2, correct? Q1 will be the clock signal for this flip-flops, FF2. Okay. So we have to find the bits, okay, at Q2. Okay, so very simple. Okay, so you can see that, okay, at the initial state, Q2 should be in 0, Q2 should be 0, okay, and Q1 also 0, okay, and this JK will be 1 and 1, okay, so Q2 will be 0 at the initial state. Okay, this is okay, no? This is 1, and also this is 1. Okay, because this is set to 1. J and K is set to 1. Okay, so this J will be 1 and K will be 1, and it is not changed. Always J and K value will be 1 and 1. Okay, and only this signal, the clock will decide the output. Okay, not J and K. Okay, okay, so you can see that. Okay, you can see that at the initial Q2 is 0. Okay, so this is the clock signal for Q2. Okay, FF2, this is the clock signal for FF2. Okay, I'm sorry. Okay, okay, so this is the input, clock input for FF2. Okay, so Q1 output is the clock input for FF2. Okay, so you can see that from here to here, up to here, there is no change at the output. Okay, okay, because this is negative edge trigger. Okay, only the change happen at the negative edges, at this edges only. Okay, so from here to here there is no change. Okay, so from here to here the q2 will be 0. Okay, and this, when this edge happen, okay, when the falling edge meet, okay, so this is a negative edge. Okay, if the falling edge is there, the flip-flops come to the active modes. Okay, so you can see that now j is 1, k is 1, j is 1, k is 1. Okay, the previous qn is 0, the qn is 0. Okay, so it toggled the output. Okay, it toggled the flip-flops output if 1 and 1 is there. Okay, so previously it is 0, and now it will be qn bar, that means 0 bar, so it will be 1. Okay, 0 bar means it will be 1, so it come to 1. Okay, then the flip-flops, that the flip-flops output will remain until next falling edge, up to this falling edge. Okay, so it will be 1. Okay, and from here again the change happen, the j and k is 1 1. Okay, and now the previous qn is 1. Okay, now it will be qn bar, so it will be 1 bar. Okay, so it will be 0. Okay, 0 from here to here, no? From here to here, because at the next falling edge the change happen. Okay, so from here to here it is staying 0. Likewise you can draw. Okay, and likewise you can draw the q3 output signal also. Okay. Okay, so now we see how this count. Okay, we see how this count. Okay, so you can see that you can see that these are the flip-flops output. Okay, these are the flip-flops output. If I write this here, q0, q1, q2, q3. Okay, so these are the flip-flops output, q0, q1, q2, q3. Okay, and you can see that okay, you can see that if you consider one clock cycle, that means one clock cycle means up to here, from here to here. Okay, from here to here. So you can see that from here to here, flip-flops will not change any value. Okay, and here it change, and then again from here to here it is not changing, and again it change, and then again from here to here it is not changed. So you can see that q0, q1, q2, q3 will change according to this clock cycle. Okay, the first cycle the value will change, at the second cycle this q0, q1, q2, q3 value will change, and at the third clock pulse again change, not clock pulse, actually clock cycle. Okay, clock cycle. Normally clock pulse means this one pulse we normally referred as clock pulse. Okay, okay, but these two clock pulses will referred as one clock cycle. Okay, so you can see that at each clock cycle this q0, q1, q2, q3 will be changed. Is that clear? Is that clear for you? If any student couldn't understand, please let me know. Okay, then I can explain it again. Okay. Okay. So you can see that at each clock cycle, this Q0, Q1, Q2, Q3 will be changed. Okay. So we will see the value at first cycle. The value at first clock cycle. Okay. So what are the value at first clock cycle? Can someone tell me? What is the value Q0? What is the value at Q1? What is the value at Q2? What is the value at Q3? See this waveform and check. Tell me. Okay. So that means at this point, up to this time. So this will be your, sorry, from here. This will be your first cycle. So what are the value?
0, 0, 0, 0.
Yeah, very good. 0, 0, 0, 0. Okay. So this will be the value at the first cycle. Okay. Then what is the value at second cycle? What is the value at second cycle at this point? What are the value at here? So this will be the second clock cycle. What is the value? What is the value of Q naught?
1, 0, 0, 0.
Yeah, very good. 1, 0, 0, 0. Okay. And what is the third one? Okay. So that means at this clock cycle, no? At this clock cycle. So it will be 0, 1, 0, 0, no? 0, 1, 0, 0. 0, 1, 0, 0. Okay. At the fourth clock cycle, at this clock cycle, sorry, at this clock cycle, what is the value?
1, 1, 0, 0.
Yeah, it will be 1, 1, 0, 0. 1, 1, 0, 0. And if you can see the fourth one, you could understand that it will be 1, 2, 3. Okay, so it will be 0, 0, 1, 0. And if you check the fifth cycle, you can see that it will be 1, 0, 1, 0. Likewise, you can check. Okay, so you can see that at the first cycle, you will have 0. So here you will have 1, you will have 2, you will have 3, you will have 4, you will have 5, like this. So up to which value this happen? What is the last value? What is the last value will be? Can anyone tell what is the last value? So it's increasing.
16.
Is it 16? Yeah. So 16 or 15?
16.
16, no? Yeah, it will be 1, 1, 1, 1, no? Is that 16? No. The last value will be this. You have 16. You have 16 value. Okay. You have 16 values, but this is 15, no? 1, 2, 1, 2, 4, 8. 16, no? Yeah, 16. 8, 4, 12, 2, 14, 15, no? The value is 15. Okay, correct? So you have 16 value. The number of value will be 16. Okay, number of value will be 16, but finally you have 15, no? From 0 to 50. So 16 values are there. 16 combination are there. Okay, from 0 to 50. Okay, you will get. Okay, is that clear? So you can see that it is counting, no? It is counting according to the clock cycle. Okay, so that is why it is called counter. Okay, so you can see that if it is counting, no? So if you want to count, let's say that 256, or let's say that you want to count 200, 200, 500, 2500. Okay, so you need to count up to 2500 from 0. Okay, so how many flip-flops you need for that counter? Can anyone tell? So you can see that here within 4 flip-flops, you can count up to 50 from 0 to 50. Okay. That means you will have 16 combination or 2 to the power 4 combination. Okay. So if you have 5 flip-flops, you can count up to 0 to 31. Okay. That means 32 combination. So that will be 2 to the power 5. Okay. So if you have 6 flip-flops, you can have 2 to the power 6 value. Okay. 64 value. That means 0 to 63. Okay. 7 flip-flops, you can have 2 to the power 7 values. Okay. So if you want to count up to 2500, how many flip-flops you need? Please tell me someone.
Well,
Yeah. So now it is okay, no? Yeah. Okay. So any problem? So if you are given a question, okay, say that you want to count up to 5000 or something. Okay. If you ask how many flip-flops you need for the counter, so what you have to do, you have to find the log to 500 value. Okay. Then you will get some value and you should approximate it to the higher, nearest higher round value. Okay. So that you can find the number of flip-flops you need to count up to this level. Okay. So any problem up to this? Okay. So I think you can understand the operation of the counter, no? Now you should be able to understand the operation of the counter. Is it okay? Okay, so we will move on then. Okay, so I think these here the that bit patterns are there. Okay, all the bit patterns are there. Okay, so here it take after the first clock. Okay, after the first clock means after this one. Okay, after this one it take. Okay, so after this one, so we get from here actually. Okay, we consider from here. That is why we get 0 0 0. Okay, 0 0 0, then 0 0 0 1 likewise. But that table shows after the first cycle, after the second cycle, so on. Okay, so you have, so it is started from 1. Okay, and this Q naught should be the LSB. Okay, least significant bit, and this Q3 should be the MSB, most significant bit. Okay, this should be changed. Okay, this should be Q3 to Q naught. Okay, because this should be LSB and this should be MSB. Okay, so in this manner you can see that the values are different. No? Here you have 8 here, here you have 4 here, likewise. Okay, so this is not the sequence actually. So you have to consider this as the LSB and this one as the MSB. So you can have 1, 2, 3, 4, 5, 6, like so on. Okay. And also it is started from after first clock cycle, but we see from the first clock cycle. Okay. So we get the value from 0 to 0, 0, 0, 0. Anyway, in any cases, okay, in any cases, after the 15 clock cycle, it will return to the initial one, 0, 0, 0, 0. Okay, I think this one also clear for you. Okay, you can see the waveform also. Okay, so you can see that after 16 clock cycle, after 16 clock cycle, because this has 2 to the power n combination. Okay, that means 16 combination. So after the 16 clock cycle, again you will have 0, 0, 0, 0. Okay, so you will come to the next state. Okay, I hope that one also clear for you. Okay, is that okay? please tell me if you have any problem. Okay, and you can see that the frequency will be divided by 2 to the power some value. So the first cycle will have 2 to the power 1, f2 to the power 1. The second frequency you have f2 to the power 2, that means 4. The third frequency you have f2 to the power 3, that is 8. So the frequency will be half. Okay. Okay. So that is the idea of the count. Okay. So you can see that this is counting from 0 to up to some level. Okay. So these are called up counters. This is up counter. Okay. From 0 to or 1 to, starting from 1 or 0, that is counting. Okay. 1, 2, 3, 4, like that. So these are up counters. Okay. And also we can make down counters also. We can make down counters. Okay. Using very simple logic circuit, using very simple additional logic circuit maybe. Okay. So I think that will be not a problem for you. Okay. And you have some example, please try to do this example by yourself also, and let's try this one. Can you try to this one? The solution is there. Anyway, try to understand this one by yourself. Take 5 minutes, around 5 minutes. So today we will try to stop, complete the counters. Okay. Then we can go to the registers, because now we are actually somewhat behind our schedule. Okay. So can you take 5 minutes and try to understand this question? The solution is there. You can read the solution, but before read the solution, try to find the answer by yourself. Please. Okay, did you try that? So I think it is not one. Okay. So actually these counters are called triple counters. Okay. Triple counters, and also it called serial counters. Serial counters, because you can see that clock is input serially. Okay. Serially to each flip-flops. Okay. Because here first clock is input to this one. Okay. Then so the output of this will be the input clock for this flip-flops. Okay. So you can see that clock pulses are input serial to first flip-flops, second flip-flops, third flip-flops, so on. Okay. So they are called, so can you hear me? Can you hear me? Or can you see my screen?
Yes, sir.
Okay, thank you. Okay. So these are called serial flip-flops. Okay. Serial counters. Okay. And some counters are there. We can give the clock simultaneously. Those are called parallel counters. Okay. So we will later learn about that one. Today we will learn. Okay. So this is the serial counters. These are serial counters. And also this called asynchronous counters also. Asynchronous. Why we called it asynchronous? Okay. Asynchronous means actually, okay, I'll come to that point next. Okay. So so you can see that here, so we will do the example first. Okay. So you can see that it is initially from 0, 0 state. Okay, before the clock input applied to the counter, the clock pulse are applied to the counter at same time. Instance V1 and again we note. So that means, okay, so we have that flip-flops. Okay. So the clock pulses are important first at T1. Okay. So first at T1, okay, input to the counter. Okay. So this will be the counter. Okay, and it will be and some time. Okay, at time 2, we don't know what is the time. Okay, so anyway, at time 2 is stop the clock. Okay, it is stop the clock. Okay, so you can see that. So final value. Okay, at t2, at t2, if we read the counter value, the output counter value, that means q0, q1, q2, and q3, it will be 0, 0, 1, 1. Okay, so it will be 0, 0, 1, 1. Okay, so this is the counter reading. Counter reading at t2. No, this is the counter reading at t2. Okay, so at t1, it will start to change the status. Okay, so after some time at t2, it take this state. Okay, this combination 0, 0, 1, 1. Okay, so how many negative going clock transition have occurred during the time the clock was active at the counter input? So you can see that this happens means q01, q11, q2, q3. So this is 3, no? Okay. So this should happen after the third clock count. Okay. This should happen after the third clock count. So it will be negative edge. Negative edge means you can see that. Okay. If I see this one. Okay. So these are negative edge. Okay. So this is one clock. Okay. This is one clock. And for the next one, it will be another clock. And it is then next one, it will be another clock. Okay, so these are negative edge. Okay, so at this point, okay, at this point, the q0, q1, q2, q3 will have 1, 1, 0, 0. No? That is simple. Okay, so you can see that it happened at the third negative. So this output will give you after the third negative edge or third clock pass. Okay, and you can see that. So this can be goes up to 16. No? At 16, again it will be 0, 0, 0. Okay. After the 16, another one. That means at 17, at 18, and at 19. After the at 19 clock cycle also, you will get the same result. No, 1, 1, 0, 0. Okay. So this can happen at first at third clock cycle, then it can happen at 19 clock cycle. Okay, so again it can happen after the 16 clock cycle. That means 35 clock cycle. Okay, again it can happen after the 16. That means at the 52 clock cycle. So okay, so I think you can understand. No, so first happen it at the third clock cycle. Then after the 16, it can be repeated. Again after the 16, it can be repeated. Okay. Again after the 16, it can be repeated. Okay. So that is very simple. Okay. So I think you can understand what is there. Okay. And try to do that one also. Okay. Okay. So, okay. So there is one disadvantage with this counters, with this serial counters. What is that? Can you imagine? One major disadvantage. Okay, that is you can see that. Okay, we already seen that the clock are input from here, and it is serially going to here, going to here, and going to here. Okay, so you can see that at this flip flops there will be little processing time. Okay, we called it propagation delay. Okay, propagation delay. It will be very little. Okay, it may be in nanosecond or it may be in picosecond. or maybe very little value. But for the high speed circuit, this one also will affect much. Okay. This type of very little delay also will affect to the high speed circuit. Okay. So you can see that when there are some processing, okay. So you can see that there should be some processing to toggle the value here. Okay. So when we send this clock through a flip-flops, there will be a processing time and the propagation delay will happen. Okay. So first cycle, we know this one also now. Okay. Is there uh, any way to delete them more? Okay. Anyway. So this is the first cycle. This is the clock cycle. Okay. So when it goes to the second one, okay, second one. So for the second flip-flops, this will be the clock input, no? For second, so for second row FF1. So this is FF0 first one, the FF1 second one. Okay. So for FF1, okay, for FF1 flip-flops 1, this will be the clock input. Okay. So there can be very little propagation delay. That means it can be shift to this line. No? If the time delay is happen, it will be shift to this side. I think you know that. Okay. Okay. So you can see that this edge and this edge may not in each other. This may be shift to very little. Okay. So you will get this kind of clock signal like this. Okay. It is somewhat shift, and here also there is a shift. Okay. Is it okay? Can you understand that one? If the propagation delays happen, it is not in the same time interval. There are some delay, very delay. So that waveform will be shift. Okay. Okay. Is it okay? Have you any problem? So you can see that, okay, due to this propagation delay, this clock and this clock is not synchronized. So that the, uh, the clock cycles are not synchronized each other. Okay, it is not synchronized. So that is we call, so this type of serial flip-flops, that the clock pulses synchronization is not happen. So that we called it asynchronous counters. Okay, not flip-flop, sorry. When we are using serial counters, okay, serial counters, okay, due to the propagation delay of each flip-flops, okay, there can be a clock input delay also, which is the input. Okay, the clock is not synchronized each other. Okay, so we called it also asynchronous counters. Okay, so there are three names actually: ripple counter, we called it ripple counter, maybe serial counter, or asynchronous counter. Asynchronous counter. Okay, so both three names can be used. Okay, so there are in so there are four number of flip-flops. So we called it four ripple counter of your serial counter or four asynchronous counter. Okay. If five flip-flops are there, it will be five ripple counter. So we can name them. Okay. Okay. Did you get this point? Okay. So you can see that it is a disadvantage. Okay. It is a disadvantage of a serial counter. Is that clear? ඒක පැහැදිලිද ඔය කට්ටියට? එතන අර ඩිලේ එකක් වෙනවා. ඒ කියන්නේ එතන flip flops එකේ propagation flip flops එක ඇතුලේ process එකක් වෙන හින්දා එතන පොඩි ඩිලේ එකක් වෙනවා. processing time එකක් ගන්නවා. ඒකට තමයි අපි කියන්නේ propagation delay එක කියලා. එතකොට due to that propagation delay the two clocks will not synchronize. Okay, the clock frequency will be changed, but if this edge are in same point, so we called it synchronized. Okay, but here it is not synchronized because there can be little shift between this clock input and the second flip-flop's clock input. So you will have the same thing for one. Okay. Okay. Now tell me. So if you consider the fourth flip-flops, okay, fourth flip-flops. If you are using four flip-flops counter, that means actually we called it modular 4. Okay, I will explain that word also. Okay, we normally refer that as mod 4 counter. Okay, if you use mod 4 ripple counter, okay, ripple counter, there is a propagation delay. No, there is a propagation delay. And can you tell me for which flip-flops this propagation delay is most affected? Can anyone give the answer? If you use mod 4 ripple counter, that means there should be four flip-flops. Okay, and also there is a propagation delay. Okay, and which one is affected by this propagation delay mostly? First flip-flops, second flip-flops, third flip-flops, or fourth flip-flops? Please tell me the answer. What is the answer? What do you think? Please tell me. If you use
fourth flip-flop.
Yeah, very good. It should be fourth flip-flops, no? So I think it is clear because you can see that, okay, you can see that this one will shift little. Okay, this one, the first flip-flops will shift little. When it goes to the second one, this propagation delay will be double. So it will be shift double. No? If we assume that all flip-flops have the same propagation delay, at the second it will be double. Okay, at the fourth, at the third it will be triple. No? At the fourth it will be 4 times. Okay, so the last flip-flop will affect by last flip-flops will be affected by the propagation delay mostly. That is clear, no? Okay, so so if you consider the worst case, okay, if you consider the worst case, that means at the last flip-flops, okay, let's say that we have n flip-flops, let's say that we have n flip-flops, okay, so the nth flip-flops will be most affected by the propagation delay. Okay, So what happened if the propagation delay is high? Can you understand what happened there? Okay. For example, I use this one. Okay, I use the first clock. I will explain it with the first flip flops. Okay, and it is also same as the fourth one. Okay, the last one. Okay, so if you consider like this, so you can see that. So if your signal, the second one is shifted from here to here. Okay, so your signal will be like this. Okay, so your signal will be like this. Okay, so your signal will be like this. Okay, the waveform will be like this. Okay, so if you get the value at this point, this clock cycle. Okay, if you get the value, I don't know whether this is clear, my writing is clear or not. Okay, so I will try to write it. These are very, this is very important point. Okay, actually in communication this is very important point. So I think this is affected in your application also. Okay, so you can see that if this clock is shifted very little. Okay, so this is shifted. Okay, now the new the actual clock pulse will look like this. Okay, so you can see that it is somewhat shifted. Okay, like this. Okay, and if you consider this clock cycle, if you consider this clock cycle, if there is any propagation and delay not happen, the value should be 1. No, value should be 1. Okay, so you can see that this signal is shifted somewhat from very little value, but if you get the value here, you can get it as 1. No, you can read that value as 1, no issue. So it is 1, it will be 1. Let's say that it is shifted somewhat here, again you can read it as 1, no issue. Okay, no any change. Okay, so likewise, if this delay is shifted to at this point, what happened? If this delay, this little delay shifted again here, no issue, here no issue. And what happened if that delay happened at here? Okay, so one clock cycle, one pulses is shifted. No, one pulse is shifted. Okay, so you can see that now this will be, the shifted signal will be like this. Okay. So what happened? So what happened? If you can consider this one, this point, okay, so you can see that at this point, at from here to here, the value should be 1, but here you read as the value should be 0. What happened? Okay, what happened? So it is misunder. So actually this is status we get. No, this is status we get. Okay, so actual value is here. No, it is shifted. Okay, it is shifted. So these are called actually symbols. Okay, these are called symbols. So you can see that these symbols are interfered with each other. Okay, these symbols are changing. No, it cannot identify correctly. Okay, is that okay for you? Can you understand what I am talking here? If you can't understand, please tell me, then I will explain it again. Okay, so you can see then if this delay happen at one cycle, okay, if this delay happen at one cycle, okay, if the delay is in one cycle, what happened? this bit are interchanged. Okay, the actual bits are interchanged. So our output will be wrong. Okay, output will be wrong. So can you understand that point? Actually, that phenomena is called as intersymbol interference. If you have learned, okay, I don't know, but communication students are learning these things actually. Okay, that means this 1 and 0s are symbols. Okay, so that 1s and 0s are changing, they are interfere with each other. මේක තේරුණා? Okay, so this so if there is a little shift, okay, මෙතෙන්ට shift වුණත් ප්‍රශ්නයක් නැහැ. එයා එක 1 විදියටම identify කරගන්න පුළුවන්. මේ වගේ හරියකට shift වුණත් ප්‍රශ්නයක් නැහැ. භාගයක් විතර තියෙනවනේ. ඒත් 1 විදියට identify කරගන්න පුළුවන් මොකක් හරි තාලෙ. So we can use filters likewise, you can use match filters likewise, then there are many instruments. Okay, so anyway we can identify this as one. Okay, so if the delay is happen to here මෙතෙන්ටවත් identify කරගන්න පුළුවන් මොකද පොඩි කැලලක් හරි තියෙනවනේ හැබැයි ටිකක් අමාරුයි මේ. හරි, දැන් මේක එකපාරටම 1 කියලා අඳුර ගන්න සමහරට අමාරුයි මේ වගේ තිබ්බොත් එහෙම. සමහරට යා මේක 0ම කියලා අඳුර ගන්නත් ඉඩ තියෙනවා. Okay, most probably it will identify as 0. Okay, but there can be some adjustment things. Okay, with the circuit we can do this adjustment. Okay, so we can most probably identify, but බැරි වෙලාවත් ඒක මේ ඩිලේ එක මෙතෙන්ටම ආවොත් එහෙමනම් ඕක අයිඩෙන්ටිෆයි කරගන්න බැරි වෙනවා. එතකොට යා තියෙන්නේ මෙතන. එතකොට මේක දැන් මෙතන තියෙන එක තමයි මෙයා මෙතෙන්ට අයිඩෙන්ටිෆයි කරගන්නේ. එතකොට මේ දෙක අතර වෙනසක් වෙලානේ. චේන්ජ් එකක් වෙලා. ඉන්ටර්ෆියර් එකක් වෙලා. හරි. එතකොට මෙන්න මේ ප්‍රශ්නේ තියෙනවා සීරියල් කමියුනිකේෂන්. සීරියල් counters. Can you understand that one? Okay, so if you maybe you can't understand it 100%, but try to understand that one up to some level. Okay, for your exam I am not going to ask the question in that aspect. Okay, in that aspect. Okay, but the understanding is important, no? For the if you are going to do a designing, that understanding will be important. Okay, so try to understand that as much as possible. Okay, so if you need any help, please tell me, then I can explain it again. Okay, okay, so if you consider, so I already told you that the worst case happen at the 4th input. Okay, worst case happen at the final output, final flip-flops. Okay, so if there are n flip-flops, okay, n flip-flops, the worst case happen at the n flip-flops, no? Okay, so what is the requirement? Okay, so you can see that, let's say that, okay, let's say that the time of this one clock pulse is t. Time of this one clock pulse is t. Okay, let's say that it is t clock. Okay, so you can see that to identify or to have a correct input, this should be this clock, the the clock time, the one cycle time for clock. Okay, so that is clock period actually. Okay, so this is clock period. This is clock period. Let's say that clock period is t, that is time for one cycle. Okay, time for one clock cycle. Okay, So let's say that it is T clock or something. Okay. And the to not happen the affected to the output, this T clock should be less than or equal to propagation delay. Okay. Can you understand this, sir? Please take 5 minutes and try to understand this. 5 or 2 minutes. Try to understand this. Is it okay? Is someone feedback? Get 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 some time and think and feedback me. Any concern? So what I told you is that, okay. So if any delay happen, so there is a propagation delay, no? Here, there should be a propagation delay. Okay. So let's say that propagation delay is up to this level. Okay. Very few nanosecond. So your output signal will be shifted somewhat like this. Okay. But if you consider this time slot, okay, if you consider this time slot, you can get the value as 1, no issue. Okay, so this should be 1 and you will get as 1. Okay, so anyhow this delay shift up to here, that is mean from 1 cycle. Okay, okay, so now your new signal will be like this. So you can see that at this point this q naught value supposed to be 0, supposed to be 1. Okay, supposed to be 1. So this is 1, no? But if the delay happen, if you read the delay, if you consider the delay, now the value is 0. Okay, so there is a bit error. Okay, there is a bit error. Okay, so what is the condition for not happening the bit error? That bit error, this t, this clock frequency should be less than the propagation delay or should be greater than the propagation delay. Can anyone feedback? Can anyone give the answer to this one? ඔකට තේරුණාද මම කියප එක? මේකට කාට හරි උත්තරයක් දෙන්න පුළුවන්ද? Yeah, you can see that there is a paragraph for propagation delay. Okay, so I give you some time. Okay, can you read this paragraph and try to understand this by yourself? Please get time because I need this understanding. Okay, I need this understanding up to some level, not totally. Okay, so can you try to read this one and try to understand by yourself? I give you 5 minutes and give me the answer for this one. Okay, give me the answer for this one. I give you 5 minutes. Please try to. So this is the propagation delay, and I am asking. Okay, I am asking for not being any bit error. Okay, clock period should be less than the propagation delay or should be greater than the propagation delay. Please answer me. I give you 5 minutes. Please try to get the answer by yourself.
You're muted.
I'm sorry, I have unmuted. Okay, now I unmuted. Okay. So, so have you get any answer? Can anyone tell me the answer? This one or this one? What is the answer? Okay, so you can see that. Okay. So this is the clock cycle. No? This is a clock cycle. If the time of the propagation time is greater than the clock cycle time, you can see that the error happened. Okay, so it is shifted total. So this one shift to this time slot. So you are when you are counting the slot, you can see that you get bit interchange. Okay, the bit you get are interchanging each other. Okay, so actually this is wrong. Here what I write it wrongly. Okay, the correct thing is clock time should be greater than the propagation time. The propagation time should be less than the clock time. Actually, this is a common sense. Okay, so you can see that if the propagation delay is very large, then the issue is happen. If the propagation delay is very large, okay, that is then the issue happen. Okay, otherwise, if the propagation delay is small, it is not happen. Though propagation delay should have maximum value, not the minimum value. No? That is a common sense. Okay, it should have a maximum value. It should have a maximum allowable value, not the minimum allowable value. No? Okay, so you can say that propagation delay should be less than 2 ns, 2 nanosecond. Okay, for a system, you can say that propagation this should delay should be lower than 2 ns. That means that is the maximum value allowable for propagation. So you can see that the propagation should be lower than, okay, should be lower than the clock cycle. Okay, so if the what is the maximum allowable time for the TPD propagation delay? It should be the clock cycle. No? If I write the maximum allowable time, propagation time, so that will be equal to T clock. Okay, so that will be the maximum TP. Okay, okay, did you understand this one? Did you understand this one? T clock should be greater than the propagation delay. Okay, so try to at least remember these things. Okay, then gradually you will understand this. Okay, so when you are doing some example, maybe you will understand this. Okay, okay, so we will see. Okay, so now what I want to tell you is that this is the nth, at the nth flip flops we will have the main problem. At the nth flip flops we will have the main problem. Okay, okay, so it is not with the first one. So NTPD, this will be the maximum propagation delay. No? This will be the maximum propagation delay. The worst propagation delay happen. Okay, this will be the worst propagation delay will be happen. If you have n bits, for example, if you have 4 flip-flops, okay, if the propagation delay in one flip-flops TPD, okay, the total propagation delay will be NTD, NTPD. No? This is the total propagation delay. So it is affected to here at the 4th flip-flops. Okay, so this is the most affected flip-flops. Okay, so always you have to consider the total propagation delay. That will be the worst case. Okay, so this total propagation delay TPD should be actually less than the clock cycle, not the one clock propagation delay. Okay, not only one propagation delay. This propagation delay is less than the clock signal. It is not sufficient. Okay, the total propagation delay should be less than the clock time, clock period should be less than the clock period. Okay, so this is actually, this one you should understand. Okay, this one you should understand, and this one you should be keep in your mind. Okay, for ripple counters, if the number of ripples, if for ripple n triple counter, n mod triple counter, okay, if the n mod triple counter is there, okay, okay, the propagation delay of the total propagation delay n into t propagation delay. This is one propagation delay. Should be less than the clock period. Clock period. So what happens if I get 1 by both part, 1 by t clock? So this greater than will be other side around, no? Other way around. So it will be less than or equal 1 by n equal t t. Okay. So what is this value? Can anyone tell what is this value? 1 by t clock period. What is that term?
Frequency of clock.
Yeah, thank you. Frequency, no? That is the frequency of the clock. That is the clock frequency. So the clock frequency should be greater than, okay, should be less than, sorry, clock frequency should be less than 1 n by TPD. Okay. So the clock frequency should be less than for this value. Okay. So you can get it from here. So this part you can understand. This part you can understand, and from that one you can get this one. Okay. So if you read the book, you can't understand this one correctly, directly. Okay. But try to understand with keep read that paragraph, maybe not enough, okay, because it doesn't give this concept, okay. It directly write this equation, okay, but you need to understand this equation and you need to know this one. At least you need to know how to apply it, okay. So please try to understand this one using this identity, okay. So this identity you can direct easily understand, okay. So this is one condition related with the serial or ripple counter, okay, and you should understand that one, okay. So if I ask you to find the maximum clock period, what is that? If I ask you to find the maximum clock period, if one flip-flops have t propagation delay, what is the value? The maximum clock frequency should be equal to n by 1 by n into t pd. Okay. So this one also you need to keep in mind. Okay. So if you know this one, if you can understand this one, and this one you can realize. Okay. Okay. So please keep remember this one. Okay. Okay. So let's do a simple question. Okay. So let's say that you have 5 flip-flops. Okay. You have 5 flip-flops. You have 5 flip-flops. Okay. You have 5 flip-flops. 1, 2, 4, 5 flip-flops. Okay. And this is a counter. Okay. So this is a 5 mode triple counter. 5 mode triple counter. 5 mode triple counter. Okay. 5 mode triple counter. So I am asking you this kind of question. Okay. So say that using this counter you need to count something. Okay, you need to count some value, okay. It may be any value, okay. It may be a pulses or it may be a goods or anything you need to count, okay. Okay, so if you have if one flip-flops have 2 nanosecond propagation delay. Propagation delay is 2 nanoseconds. Okay. So what is the maximum frequency you can count? What is the maximum frequency you can count? The maximum speed, no? That is maximum speed. What is the maximum speed you can count? Can you try to find that one? Maximum speed or maximum frequency. No, maximum speed means how many counts per second. How many count per second? How many maximum count per second? So that is maximum speed. No, it is a speed, counting speed. Or we can say that it is a frequency, counting frequency. Okay. So what is the maximum speed or maximum frequency? Please tell me the answer. Please tell me the answer. 0.1. See, it is hertz or what? This is nanosecond. Is it hertz or gigahertz or what? Okay. So you can see that the propagation delay is 2 nanosecond. So there are 5 flip-flops. The total propagation delay will be 10 nanosecond. Okay. Total propagation delay will be 10 nanosecond. Okay. So your clock cycle, clock, yeah, I think maybe correct. Okay. So your clock pulse, okay, your clock period should be greater than this total propagation delay, this NPD. Okay. So your clock period should be less than 10 nanosecond. Okay. So at least you need 10 nanosecond, 10 nanosecond gap between two count. No, this is what that means. At least you need 10 nanosecond gap between two counts. Okay. So if I ask the frequency, okay, so for 10 nanosecond, 10 nanosecond, you should have at least one for one count. Sorry, for one count, you need at least 10 nanosecond for one count. Okay. So how many count per second? So you have to divide by this side one 10 nanosecond and this side also 10 nanosecond. Okay. So that is the counting frequency. No? So the counting frequency, the maximum counting frequency will be 1 by 10 nanosecond. Okay. So you will have 0.1 nanosecond means 10 to the power 6 now, 10 to the power minus 6. So it will be 10 to the power 6 hertz, and it should be 0.1 gigahertz. No? So this is the maximum frequency you can count. Okay. Okay. Now, okay. So you can see that if we use n flip-flops, okay, if you use n flip-flops, there are 2 to the power n levels. Okay, there are 2 to the power n levels. Okay, but if you want to get less level, if you want to get less level, that means you need to get the levels less than, you need to get levels, number of levels less than 2 to the power n. Okay, so this number of level we called as modulo actually, modulo or mod. Okay, okay, so the number of levels or modulo for n uh, bit triple counter is 2 to the power n. It is clear now. We can get n number of n number 2 to the power n number of levels if we have n flip-flops. Okay, if you have 4 flip-flops, you can get 0 to 15 value. That means 16 number of levels you can get. Okay, so this number of levels we called as modulus. Modulus, no? Modulus or modulos maybe. Okay, so you can see that if you have n number of bits, you will have 2 to the power n number of modulos. Okay, modulos. Okay. So if you want to get less than that modulos, there can be some, there should be some modification to the original flip-flops. Okay, there can be some simple modification to this n triple flip-flops. Okay, so that can be achieved by simply adding a combinational logic circuit to the flip-flops, or you can have different configuration of flip-flops. Okay, instead of using the clock triggered in flip-flops, maybe you can use a preset and clear type clock flip-flops. Okay, so likewise you can do some modification and you can do that as you wish. Okay, like this. Okay, so we are not going to study these things. Okay, these are very simple actually. We no need to use our time for that one. I think you can understand what I'm talking. Okay, okay, okay. So now we need to study. So these are asynchronous uh, one, no? Serial counters. Okay, and we have to know about the parallel counters also. Okay, so you can directly give the clock impulse, clock input simultaneously. Okay, and this is the basic logic circuits. Okay, this is the basic logic circuit. Okay, and there is a additional combinational logic circuit added. Okay, added, and you can see that this is clock, and the clock key is given simultaneously for all the flip-flops. Okay, so I think this also can be understand by yourself. Okay, this one also you can understand by yourself. Okay, please try to do this one by yourself. Okay, then anyhow I will explain this. Okay, but don't wait until my explanation. Please try to do this by yourself. Okay, can you do this one by yourself? Okay, so very simple. Okay, so again you have to consider the JK function table. Okay, so you have some values, and you have to you have to uh, you have to consider the input, output, and the clock edge. Then you can find the output here. Okay, so can you try to do that one? So I hope you can do it by yourself. Okay, so it is the same as we have done. Okay, so you can see then if you get the basic understanding, you can use it for analyze any other circuit. Okay, so please try to do this by yourself. Okay, and So please try to do this by yourself. Okay. Because now it is almost 1. Okay. Actually, I hope to finish this one also for today. Okay. But I couldn't do it. Okay. So anyway, try to understand this by yourself. Okay. And if you can't, I will help you how to do this. Okay. I hope you should be able to do this one. Okay. So shall we stop the session now? Okay. Before the okay. Before winding up, do you have any question? I think that you couldn't understand that propagation delay things. Okay, I feel it. Okay, because you didn't answer the question that I asked. Okay. So anyway, try to understand that one also by yourself. If you need any help, please ask me. Then I can again help you. Okay, you can individually ask me if you have any problem. Okay. So first you can discuss with your batch, with your friends. Okay. If you can't understand that one, please ask me. Okay, then I will again help you. Okay. So anyway, try to do this one also. Okay. You can get help from, you can help from each other, and I hope you can do this one. Okay. So shall we wind up now? Shall we wind up?
Okay, sir.
Okay. Okay. Thank you.
Thank you, sir.
Okay. Thank you.